wish you a fruitful discussion. Back to you.
Thank you. Thank you very much, Mr. Lee, for giving us this inspiring speech. Indeed, INSOILFER just established last year, and we for sure will working with all stakeholders, farmers, governors, as you mentioned, communities to ensure the food security and mitigating climate change, because soil fertility is so important for the global food security. So without further ado, I would like to invite our first presenter for the first presentation, Dr. George Marshall Nzanda from the Cameroon, and he is the chair of INSOILFER and also the member of the international ITPS, International Technical Intergovernmental Technical Panel on Soil Use of FAO. So, Dr. George, the floor is yours. Please give us your presentation. Thank you. Over to you.
Thank you very much, Yuxing, for giving me the floor. Let me share the screen. Okay. Once more, Yuxing, thank you very much for the floor you are giving to me. I want to say welcome to all our participants, to all of them, as we gather for the INSOILFER webinar on soil health as a prerequisite for crop production, the relevance for organic carbon. As you know, soil health is the bedrock upon which sustainable agriculture stands, and the role of organic fertilizer is enhancing this vital foundation cannot be overstated. Our collective exploration today will shed light on the pivotal relationship between soil health and fruitful crop production, emphasizing the significance of organic fertilizer in this respect. So our network is soil fertility and fertilizer, INSOILFER, with the aim to adopt and implement sustainable soil fertility management, avoid the underuse, misuse, and overuse of fertilizer, and reduce the environmental and health impact of sustainable fertilizer use. Our network also is dedicated to channeling collective action towards sustainable soil fertility and fertilizer management with the vision of achieving health and fertile soil by 2030 and contributing to the transformation of agri-food system. So now we launched the International Network on Soil Fertility in July, and we had our working group meeting at the end of the year in November. And our structure, our network has a structure as follows. We have a chair, and we have working groups leading by vice chairs. Among us, we have the coordinators for every working group. And also we are working with reference institutions, because we cannot do it without working with reference institutions that help us to achieve our goals. The names of technical committee also are there as a structure and governance. During our last meeting, we have pointed them, as you can see. So here is the structure and governance of INSOILFER with GPS coordinator, chair, vice chair, technical committee, and reference. Our network also has different working groups, as I was saying. The working group 1 is concentrated mainly on soil fertility and nutrient monitoring system. The working group 3 is a sustainable soil fertility and fertilizer management. And the working group 3 is a fertilizer safety and quality assessment. For the working group 1, we have different main objectives, but amongst them, we have the 3 keys that are enhancing or building capacities on soil fertility, monitoring, and soil nutrition, plant development, and evaluation. We can also support, or we are supporting, the decision-making on soil nutrient management, soil nutrient budget, monitoring system, and climate change mitigation at the global, national, and the local level, because no country will be left behind for these objectives. We also have objectives to create a global soil nutrient monitoring system and fostering data sharing in partnership in working group 1. So in working group 2, we have a role to locally adapt soil sustainable use management practice oriented to improve soil fertility, crop nutrition, and nutrients use efficiency. We also have the role to avoid underuse, misuse, and overuse of fertilizer through the optimizations of nutrients, use efficiency, and fertilizer recommendation. The development of capacity also one of our goals in the working group 2, in group 2, yes. So in the working group 3, the quality and safety of fertilizer, this is also one of the key important objectives that we have. And we use to check the sample preparation, the NPK, heavy metal, biofertilizer. As you can see, the working group 1 to working group 3, we care about capacity development because we think that when people have the ability to achieve this objective, they can do it by themselves. So one of our job objectives is capacity development for quality assurance of analytical procedure, laboratory staff. We also the regulation and policy on the safety and quality of fertilizer. So we also know that the webinar says we have these objectives because we think that to achieve the capacity building, we need to have more webinars. And this is the first one, as Yusing was saying, and we have intention to have most of them in the near future. And these are the capacity that we are trying to develop in the topic, different topic, measuring soil fertility, soil and crop nutrition, model for evaluation, case soil fertilities, and a lot of other topics that we have intention to achieve. Dear colleagues, thank you very much for presenting this overview of our activities.
Thank you very much. Thank you very much, George. So for introducing of the INSOILFER, the structure of INSOILFER International Network on Soil Fertility and Fertilizers. As you mentioned, there are 3 working groups for INSOILFER. The first one is monitoring nutrient soil fertility and nutrient monitoring system, because we need to know our soils before we manage them. And the second working group is the soil fertility fertilizer management sustainably. We need practices to manage, good practices to manage soil fertility and fertilizers. And the number 3 working group, also very, very important, is the fertilizer safety and quality assessment. The quality of fertilizers impact the soil fertility because we input a lot of fertilizers, chemical, physical, and biological fertilizers. So we need to ensure the good quality of fertilizers before we input them in our soils. So thank you very much. Thank you very much, George, Dr. George Nizana, for providing this presentation. We understand the INSOILFER, and we are here. Welcome all the participants to join our INSOILFER network. We can together to support the soil fertility and fertilizer management sustainably. And please also, if you have any questions, please put your question in the chat. Then we will check the chat during the discussion session and select the questions and answer the questions by the speakers. Without further ado, I would like now to invite our colleagues, Vinisa, to give us a presentation about the objectives and the personalities of soil fertility network. Over to you, Vinisa.
Thank you very much, Yushin. Let me share my screen. You can see my screen, right? In presentation mode. Okay. So good morning, good afternoon, and good evening to all the participants. Thank you very much for joining us today. My name is Vinisa Sainz Santillan. I work for the Global Soil Partnership, and I have the pleasure to assist in the coordination of this network. So today I want to share with you some information about the network for those who don't know the network yet, which are the general goals and which are the potentialities of being part of this network. So INSOILFER is promoting an integral concept of soil fertility. So soil fertility is the ability to sustain plant growth by providing essential plant nutrients, but also by promoting favorable chemical, physical, and biological soil properties. So INSOILFER is promoting an integral concept of soil fertility, taking in consideration these three important soil properties. But these three soil properties are very important to keep soils healthy. However, our soils are in great danger. We know that approximately a third of the soils in the planet are in danger, and they are already presenting degradation at some extent. However, it's been extensively documented that sustainable soil management could produce up to almost 60% more food. So it seems this is the way to go for food production. So are you seeing my whole screen? Yes, I guess, okay. So even if soils are in danger, and they are one of the main drivers of that are damaging soils and threatening soils is soil fertility loss, soil nutrient loss. So because of the continued and intensive agriculture, the nutrients needs to be replenished to soil. So when this doesn't happen appropriately, then fertilizers need to be added to the soils in order to keep their nutrients in the soils, and this can be done by adding organic or mineral fertilizers. So INSOILFER aims to contribute and to produce to a sustainable production by the sustainable use of fertilizers and avoiding the fertilizer overuse, misuse, and overuse. So one of the most important aspects of INSOILFER is that it aims to contribute to restoring the nutrient balance and bringing back nutrients to soils in different forms, in organic forms, inorganic forms, and alternative nutrient sources. So what to do in order to sustainably replenish nutrients to soils and prevent or reverse nutrient imbalances? of course, the judicious and the sustainable use of fertilizers, among other actions that can be taken. And one of the most important tools in order to promote the judicious use of fertilizer is the International Code of Conduct for the Sustainable Use and Management of Fertilizers, simply known as the Fertilizer Code because the name is a little long. This tool is important as a guidance because it addresses the sustainable use and management of fertilizers and ultimately to avoid the underuse, misuse, and overuse. And this tool is very helpful because it includes guidance and recommendations for key stakeholders like the government, the private sector, the industry, agricultural extension and research, other users like the laboratories, and of course the farmers. And it includes different actions to be taken in order to avoid the unsustainable use of fertilizers and recommendations, for example, like the composition, permissible limits, recommendations for governments, harmonized metrics and protocols, capacity development, and of course topics such as soil fertility and plant nutrition. So INSOILFER is also promoting an integral approach for accomplishment, fertilizer use efficiency, and this INSOILFER is considering different options like nature-based solutions, management-based tools and technological tools, nature-based solutions such as soil organic matter addition, the use of legumes and nutrient fixers, biofertilizers and biostimulants, cover crops, etc. And then with respect to management-based tools, for example, of course, taking in consideration the 4 R's, the fertilizer source, rate, time, and place. And also without leaving aside technological tools like weather alerts, sensors, spectroscopy, etc. So which are the INSOILFER targets? Our colleague and INSOILFER chair, Dr. Nsana, already explained the network structure, but in general, the targets of INSOILFER we will be addressing the targets through the work of the different working groups. So as been explained, working group 1, soil nutrient and monitoring system. You can see the details of the different work plans in the website of the network, but this is just a few more information about it. So we intend to improve the knowledge and enhancing capacities on soil monitoring and soil nutrition plan development and evaluation through capacity development on the topics of soil nutrient fluxes, stocks, inputs, and outputs at different scales, the identification and the simplification of different key indicators to define an integral concept of soil fertility, and also support the development of national and global soil nutrient budgets and soil fertility maps, and also supporting decision-making on soil nutrient management through different actions, for example, calibrating and testing of practical field tools to evaluate the status of soil fertility. Then the working group 2, soil fertility and fertilizer management, aims to promote and disseminate sustainable soil and fertilization management practices at the farm scale, and also to empower innovations and alternative nutrient sources that optimize nutrient use efficiency. So there are different areas of work: the identification and compilation of promotion of successfully field-tested and calibrated soil management practices that have proven to increase soil fertility, crop nutrition, and other important aspects of crop soils. Also, the identification and the promotion of practices that, in addition of maintaining, of course, the crop yields, are also preserving soil fertility, but also reducing the collateral damages, or and that also aim to reduce greenhouse gases emissions and other damaging effects to the environment. And also we are promoting an environmentally friendly, but also nutrition sensitive approach to agriculture, not only oriented to increase crop yields, but also to increase the nutritional quality of crops. Then working group 3 is focusing on soil and fertilizer safety and quality, and mainly focusing on 3 aspects: harmonization of the metrics, the protocols for assessing the quality and the safety of fertilizers. Also promote and disseminate analytical quality assurance and improve the knowledge of the regulatory frameworks and laws, permissible limits in the fertilizer use. And we are addressing topics like the ones you can see here, harmonization of laboratory and analytical protocols like sample preparation, evaluation of the nutritional content of fertilizers. We are also working for the harmonization of heavy metals and biofertilizers, capacity development for quality assurance. We will launch this year our ring test for quality assurance, and also we are working on regulations and policies for assessing the safety and quality of fertilizers. So which are the specific potentialities that we are envisioning that we can achieve through this network? First, in the topics addressed by the working group 1, we are envisioning that we can accomplish to establish a soil nutrient monitoring system. In the case of working group 2, we are envisioning, and the ultimate goal is also to establish a fertilizer recommendation system that is useful for farmers and technicians. And in the case of working group 3, we are aiming at achieving globally harmonized metrics for assessing what we are adding to the soils. That means for assessing the quality and the safety of different sources of fertilizers. So what are other potentialities of a network that is specialized in soil fertility and nutrient dynamics? We aim to contribute to food security, to restore the nutrient balance, of course, improve the nutrient use efficiency. Agricultural production needs also to be improved in a sustainable way. It's very important for us to work toward the reduction of the environmental impacts of agriculture. Then it's also important the identification and the empowerment of sustainable, cost-effective agricultural management practices to improve and monitoring approaches and support this part, and also the identification and to address the policy gaps on fertilizer regulation, quality, and safety. So today we are going to talk about the alternative nutrient sources and innovations that are necessary to restore the nutrient balances. So it's very important for us to understand and to work towards the better knowledge of the different nutrient sources that can be added to soils, organic and inorganic. There are other and alternative nutrient sources such as reused and recycled nutrient sources. And today we have a wonderful guest that will explain this better, this topic, and organic fertilizers and alternative nutrient sources. So this is my last slide. Thank you very much, Yuxin. Back to you.
Thank you very much, Vinisa, for introducing the INSOILFER and its objectives and some work plan we are going to do in the future. But for sure, together with all the partners of INSOILFER. So without further ado, thank you very much. And without further ado, I would like to invite our main speaker of today, Dr. Adele Muscalo from the University of Reggio Calabria from Italy. So Dr. Muscalo from Italy is a soil scientist specialized in the area of soil fertility and soil quality. She completed her PhD in food science at Nepal University, and she started her professional career as a researcher at Mediterranean University of Reggio Calabria, where she is still working as a full professor in soil chemistry and ecology. Yeah. Her main research areas include characterization and dynamics of soil organic matter. Knowledge derived from her research activities are disseminated in scientific community and industry, and used to develop management guidelines, recommendations, and tools for sound soil management. She is the author, co-author of over 200 papers in the international journals, and also she is a member of the Intergovernmental Technical Manual on Soils of FAO Global Soil Partnership. So today he will present the relevance of organic fertilizers to soil health and food security. So Dr. Adele Muscolo, the floor is yours, please. Thank you very much.
Thank you very much for this presentation. Thank you for giving me this opportunity. Good morning, good afternoon, and good evening to all the participants. I will share my presentation. You can see this. You can see the presentation?
Not yet. Okay.
Yes, it's okay now. Yeah.
Yeah, I can. Okay. Thank you very much. I am really happy to share with you my presentation that today is focused on the relevance of organic fertilizer for soil health and for crop production. Our research was mainly focused on soil fertility, but soil fertility doesn't mean soil health. Now our research is mainly focused on soil health because an healthy soil is a fertile soil. Healthy soils support the ecosystem functioning. That is really important.
So we can see the page 4. So can you move it to the first page, first slide?
This is the first one and the second one. It's okay?
We can see the page 4 from my screen. Okay, now I can see the page 1. Thank you.
Now it's okay?
It's doing very well.
Yes.
Okay. The healthy soil support the ecosystem functioning. That is really important for the environmental equilibrium because healthy soils are able to store more water, to improve the filtration, to capture more carbon, to improve soil biodiversity and soil function, and this is reflected in a better productive capacity of the soil. We all know that soil provides 95% of the food that we daily eat, but the dirt of soil globally is already degraded, and this reduces the quality and the quantity of crops and, of course, the food produced. In Europe, over 60% of soil are unhealthy, and this is due to...
Sorry, can you put it in the full screen?
But it's in full screen.
No, we see it's not a full screen from our...
I don't know, but when I put this in, this is a full screen now?
No.
I don't know what happened, because I put full screen, but I don't know, presentation. Now?
No. So please go ahead. Please go ahead. We can see but your screen, but not full screen.
I don't know why. Without, so.
You will send someone, right? Yeah.
Now?
No.
No.
Adel, maybe if you have two screens, if you stop sharing and share again the other screen, that will work.
Okay,
Stop sharing and then share again with the selecting the other screen.
Okay, stop sharing. I don't know. And I can visualize. Now?
No, you need to share your screen. You are not sharing anymore.
Okay. Now?
No, it's the same, but otherwise go ahead.
I don't know.
Yeah.
Please go ahead. Go ahead.
Okay, I go. Yes. In Europe, over 60% of soil are unhealthy due to unsustainable management of the land, sealing, contamination, and overexploitation. This is also combined with the negative impact of climatic change, and in particular way of the extreme weather events we are assisting. Now the share is blocking. I don't know what is happening today. Oh my God. Healthy soil represents a prerequisite to achieve the sustainable development goals because we know that the unhealthy soil is important for food regulation, for climate mitigation, change mitigation, for the foundation for human infrastructure, because provide a lot of materials that we use daily for the industry. Provide fiber and fuel a part of food. It represented the habitat for the organism below and above soil. It's important for carbon sequestration through the vegetation, and for nutrient cycling. That is important for soil microbial nutrition and plant nutrition. It's important for purification of contaminant in soil, because purify water, but also keep and maintain the contaminant, reducing the effect on vegetables. Is a source of pharmaceuticals, because a lot of pharmaceuticals are microbial produced, and they represent our historical memories. All the service, the ecosystem service that soil give us represent a global economic value that is approximately $1.5 trillion per year, and the soil, an healthy soil, give us for free. In this slide, I want to show you that the healthy soil is deteriorating, and this is due more for using in agriculture artificial fertilizer. The artificial fertilizer can provide short-term benefit because we have a prompt answer from the crops, but at long term, we have severe consequences because we have a soil toxicity and a decline in soil fertility. I don't know why it's blocked the presentation. I have problem. Vinicia, do you want to try to share you this presentation?
Of course, yes, Adele. Let me share. Of course, don't worry. I will.
Because I don't know what's happened with my.
Okay, so please stop sharing, and Vinisa,
Okay.
please share the presentation.
Okay.
This one. Okay. In this slide, we can see what is happened because we have a global population that is rising and the land resource is limited. So we are, of course, involved to use more pesticides, biocides, and chemical fertilizer. And we are reaching an excess of their utilization because we need to produce more. This has an effect on microflora in soil, in particular way on fungi, protozoa, bacteria, cyanobacteria. And this can have an effect, a short-term effect, that is pollution of soil, air, and water, with consequence on the natural ecosystem, because this causes an imbalance in the soil ecosystem functioning. But in the long term, we can have damage to all the environment, and in particular way also to the status of human well-being. Next. This we have to address these challenges, trying to transition it to utilize natural resources. Specific organic material as fertilizer that can be used to preserve the environment from the chemical fertilizer and increase to the soil biodiversity. This shift aims to enhance the soil properties, chemical and biological, and foster the advancement of sustainable farming, leading then to environmental benefit. The use of organic fertilizer offers numerous advantages, including cost effectiveness, but much more enhance the soil structure, texture, and aeration, improvement in soil water retention ability. And this can promote the healthy root development of plants and consequently the growth of crops. The use of fertilizer can contribute to the mitigation of climate change, storing up to an extra 1.85 billion tons of carbon each year. This corresponds to 7 billion tons of CO2, around the same amount of CO2 emitted every year by the global transport sector. So we have an advantage for the environment. What are the organic fertilizer? What made of? The organic fertilizer generally are derived from raw material, organic raw materials that come from plants or animals. The nutrients that are contained in organic fertilizers, such as nitrogen, phosphorus, potassium, but also other nutrients, also micronutrients, other macronutrients, are released in soil through the breakdown that are operated by soil organisms, in particular way by microorganisms, important microorganisms like bacteria and fungi. The organic fertilizer that we can see in the previous one, in this slide, are generally peat, bone meal, wood ash, dolomite lime, but also manure, green manure, poultry litter, compost, and vermicompost that we can produce also by waste. How the fertilizer can work, the organic fertilizer work? The organic fertilizer can work with a direct mechanism and an indirect mechanism. The two mechanisms operate in soil contemporarily. The direct mechanism is direct because affects directly the microbial community in soil, because represent the food and an effective energy source for soil microorganism. This, as a result, increase the microbial community composition and diversity. The indirect mechanism act also indirectly on microbial community, because this mechanism include change in bulk density, water holding capacity, soil structure, and that consequently affect the soil biodiversity and the metabolic activity of a microorganism, such as the production of enzyme activity that are involved in the nutrient cycling. The efficacy of this fertilization depends by various factors that include the type and the composition of the fertilizer, the system of culture that we use, if it's a monoculture, polyculture, the combination of species that we use in rotation, the population density, and the environmental condition of the detected areas. This is not the last my presentation that I sent you this morning. It's the previous one, but never mind. In this slide, I can show you difference between organic and chemical fertilizer, because we have a substantial difference in the action of this fertilizer. And this is what I want to express to you, because the synthetic fertilizer act directly on the plant, because feed the plants, with give nutrients only for plants. The organic fertilizer feed the soil, and this is a really important difference, because when we add organic material, we activated the detritus chain in soil, and we increase the soil microorganism and the soil biodiversity, because increasing the soil biodiversity and soil microorganisms, we have more soil nutrient and more different plant nutrients. This is reflected in increase in root morphology, in root growth, in the rhizosphere activity. We have a more microbial life, more microbial activity. We have more organic matter, humidified organic matter. This maintain and retain more substances, improve soil aggregation. This is reflected in strong plant with more flower number, more flower yield, more fruits, so more crop and more food. This is a slide that also show you the economic benefits and the environmental costs of the two kinds of fertilization. Organic amendment improve soil fertility and bacterial diversity, but reduce the input on the environment. So we have a low environmental cost, because reduce the nitrogen runoff, the emission in the atmosphere, and the runoff of and the leaching of nitrogen in the groundwater. But we have also a better growth of crops. If we use the inorganic fertilizer, we can have acidification of soil, inorganic N surplus, nitrogen leaching, nitrogen runoff, reduce the crop health, because we have a competition also between fertilizer, because we so many studies only a part of a fertilizer and not all, and then we have more emission. In the on the right, we can see that we have an increase in the bacterial community dynamics and key gene abundance dynamics. So we have more bacteria and more diversity. The next one, soil health. It's really important. So we need to assess if a soil is fully healthy. And in what way we can assess it? The assessment is based on soil quality parameters that guarantee sustainability of crop production in agricultural lands. Numerous studies and researchers showed that soil biota components such as microbial community, abundance, diversity, activity, and stability are a really important indicator of soil quality. So, why this? Because if the soil community, the soil microbial community is important in the decomposition of organic matter. They produce the phytohormones that are important for the growth, the rooting of plants, the seed germination, the maturation of seed. They participate to nutrient cycling, so we have increased the nutrient uptake because the organic matter is degraded. The symbiotic relationship, because we have a symbiotic assessment is really important. And then we also can have soil structure and aggregation that improve because we have the microorganisms that produce also the ligands in soil that link the aggregation. If we have endophytic colonized plants, we can have a plant more resistant to salinity. And more microbial diversity is important for the biological control agents against the pathogens. So all this is reflected in the quality of soil and in the healthy soil. Here, this is an experiment when you can see the plant rhizosphere, that is the narrow zone of a soil near root system, that can sustain crop production with balance or reduce the level of agrochemicals input. Why this? Because all the little balls green that you see are the microbial community around the roots. The microorganisms produce antibiotic because are important for their survival, and this impede the pathogen attack to the roots. Next. In this case, the root purchased to microbial microorganism the photosynthesized that are carbohydrates, organic acid for their survival. This is a symbiotic beneficial relationship between microorganisms that reduce the pathogens and the roots that is in healthy and grow well. What it's important also to know, we speak about healthy soil, but healthy soil is strictly connected to human health. In this slide, we can see that if we have a rich microbiome in soil, we have an high functionality and diversity in soil, high numbers of microorganisms. This is reflected in good soil health because we have an efficient nutrient cycling, high suppressiveness, high resilience, good plant health with many deficient compounds, good structural compounds, many micronutrients and micronutrients, and good taste. This is reflected in good human health and well-being because we have a balanced gut microbiome and adequate good health. Instead, if we have a simple microbiome, because we have a reduced microbiome due to the addition of chemical fertilizer that, of course, reduce the microbial biomass that are not interested in transforming organic material to have nutrients, because some macronutrients they can have from what we add. We have a poor soil health, poor plant health, and poor human health. Organic fertilization practices does not only promote sustainable agriculture, but also is important for nutrient-dense and health-supporting food supply. And this contributes to human nutrition and overall to human well-being. When humans consume crop grown in organic fertilizer soil, they receive not only sustenance, but also a diverse range of essential nutrients that are vital for optimal health. In fact, the numerous research that we are conducted just now in the last year is demonstrating that soil is the foundation of nutrition, not only for plant, but also for human. 18 nutrients that are necessary for plant growth and human health come from soil, from a soil in full health and rich of nutrients, because the plants are vigorous, is rich of nutrients, and this pass to human. We know that over 2 billion people suffer from micronutrients deficiency at now, because a single micronutrients is involved in the metabolic pathway of human metabolism. And this is important because a deficiency of this nutrient can lead to numerous diseases in human. So what we need to do is increase the soil organic matter content in soil, to minimize the tillage, and to keep soil surface covered with crop rotation, to have a sustainable soil management that ensure a soil rich of nutrients, an healthy soil. Just because now we are shifting versus an organic fertilization, we need to have more organic fertilizer. In this sense, in recent time, there is an emphasis on the research and development of using organic waste to produce fertilizer. Transforming food agricultural residues in fertilizer is important because reduce the pressure on the environment. At the same time, we can have a benefit for soil and reducing synthetic fertilizer, and a direct benefit for food production. Fertilizer produced from waste represent an example of a circular economy. We are moving versus circular economy to save money. The predominant technologies that are employed at the moment include anaerobic digestion, and biotechnology, which use organic byproduct enriched with microorganisms to produce fertilizer. All the products that we obtained with this transformation result in fertilizer with good properties for soil health. These are representative of the technology that we are now using, that is the composting, that is an aerobic transformation, and they produce compost rich in nutrients. We have the digestate produced with an aerobic digester, and that produce biogas and a bioproduct that is rich also in carbon and nutrient, and vermicomposting that is also rich in carbon and nutrients, but also is rich on microorganisms, and this can be useful to increase the soil biodiversity. This is an experiment that we did in my lab with an European project funded by European Commission. And we produced a different fertilizer from waste. One is produced from agro-industrial waste, that is sulfur bentonite plus orange waste that come from the juice orange industry. And digestate a compost produced always with orange waste. And we see in respect, we fertilize the alkaline sandy loam. After 6 months, in comparison to chemical fertilizer, we analyzed the soil. And only the soil without crops inside. We see that we have an increase in organic matter and microbial biomass, and also in the activity that are representative of oxidative reductase activity in soil. This is really important because all the fertilizers produced increase soil health and soil fertility. Then we produced also different compost starting from different waste, organic waste, and we have the same, of course, experiment on soil to demonstrate if all the compost can have positive effect, even if are produced starting from different waste. And we have the same result. The soil treated with all the compost in respect to the control that is chemical fertilizer improved their chemical, but also the next one, their biochemical properties, like microbial biomass and bacteria, fungi, actinomyces, and some enzymatic activity. This means that the fertilizer derived from waste material can have a good relevance and a good efficiency. It can be used to improve soil health and soil fertility. All types of bioproducts that we produced resulted had a positive influence on soil characteristic, added the nutrient, increased the carbon, also the carbon stock, because we analyzed also the stable part of organic matter in soil, and increased the microorganism and also their biodiversity. This can preserve long-term soil fertility. Well, what can I suggest? Of course, in some part of the world, people need to have more crops produced fastly. So they are using more the chemical fertilizer. What can I suggest? That the use of chemical mineral fertilizer conjuntly to organic fertilizer. So we can have a double benefit. So we can have the nutrients that can be promptly available for plant nutrition, but at the same time, the organic component of the fertilizer can increase the soil biodiversity, the ecosystem service. So we can have both service for plant and soil. We preserve soil health, increase fertility, and crop production. This can be a solution to gradually shift from chemical fertilizer to organic fertilizer, using a combination of both to have both results that are important for some countries. So at the moment we're assisting the current focus on agriculture. We have a low crop diversity, high mineral fertilizer rates, high greenhouse gas emission, and soil degradation and nutrient imbalance. We have to shift to sustainable agri-food system to have long-term productivity, to mitigate the climatic change, to of course, have a minimal environmental impact. So we have to shift also gradually to improve soil fertility, but starting to substitute also gradually the chemical fertilizer with organic fertilizer. So a direct, symbiotic relationship exists between healthy soil and the production of nutrition and high quality food. If we have an healthy soil, we ensure the sustainability of agricultural system, but also we contribute to the production of food that can promote human health and well-being. Thank you for your attention. I apologize for the inconvenience with my presentation, but I hope to be clear in this.
Thank you very much. Thank you very much, Professor Adele Muscolo. So don't worry, every time this happens every time for this, international connections from the webinars. Thank you very much for your presentation and your research regarding to the organic fertilizers, organic agricultures. So indeed, we learned a lot from your side about this very important topic for the soil fertility and the fertilizer society, the network. For sure, we need to promote organic fertilizers, but at the same time, as you mentioned, it's better to start organic fertilizer together with chemical fertilizer, because in many countries, in many regions, it's the production should be ensured for the food security. And I see many questions regarding to this question. So thank you very much again. So I think now I thanks to all the presenters for the excellent presentation and the contributions. Now I think we can have the time to move on to the discussion part of our webinar. I selected some questions. I would like to start from Professor Muscolo, because you are here. And I think one question is very similar to what you mentioned. Can we use only organic fertilizers without inorganic fertilizer? Do you think it's possible? I think it's also my question. So yours.
It's possible to use only organic fertilizer. Yes, it is possible. We have now because we are working on two different projects funded by European Commission on the sustainability of organic fertilizer, also in respect not only soil but the environment. So we calculated the water footprints, also carbon footprints, everything else. But we have a different experimentation in field on nuts, prey, and on different horticulture plants. And we had incredible results, not only on the productivity, because the productivity increased also on 20–30% respect to the others, but on the quality of crops. Because in the crops, in particular in the horticulture that we use the tomato, pepper, onion, and broccoli as crops, we had an increase in polyphenols, antioxidant substances, and vitamins. But also in the nuts that we are working with in field with Ferrero, that is produced the nuts in the area close to Naples, but increased a lot the quality of nuts. And also we had the same result on olive trees. We had a 30% more of productivity, but also the quality of oil in respect to the fatty acid increased. So I think that it is possible. You have to have a good organic fertilizer, to know your soil, the chemical characteristic of your soil, to adapt the doses of your fertilizer to the the kind of soil.
Okay, thank you. Thank you very much, Professor, for your answer. And it's very clear from your research, organic fertilizer can support food crop production, food security, and also at the same time can improve the quality of food. So, but should have very good practices, should include good quality of organic fertilizers. So that is very clear. I think sure we should promote the practices, but we still need to consider good practices. Thank you very much. And another question to you is that you mentioned that soil health doesn't mean soil fertility. So can you please explain more about it? Why soil health doesn't mean soil fertility, please?
The difference between soil health and soil fertility is a big difference, because soil fertility means that the soil has a productive capacity. So a fertile soil can be a soil that we also have fertilized with nitrogen, phosphorus, potassium, because it's able to produce foods. The difference is that a fertile soil is not an healthy soil. In some cases, in the majority of cases, is a man that is able to work even if as a disease, but he is able to work, but as a disease, is not in full health. The same is for the soil. The soil is a full health, is able to produce, so it's a fertile. But this is a fertile soil, is fertilized. It's not means that is an healthy soil. It can have a reduced microbial community, can have not a range of good nutrients, but a reduced nutrient in soil, and so it's able to produce, but the quality of the food produced is scarce, not good. Can be missed of some important elements that are not in soil.
Okay, thank you. Thank you very much. I think another question to you. Sorry, too many questions. I think the audience are very interested about your presentation, and then they pose a lot of questions. So, the question is, in many areas, there is no enough organic resources. So then, maybe do we consider recycling human organic residues as the source for the soil fertilization? Which parameters would you monitor to ensure a safe use of human, residues? Can that be the resources of manure, and how to ensure the safety? And do you have some experience or research related to this? Because
with the manure, they want to know if they can use manure for fertilizer soil.
Yeah,
of course, generally, if you want to use manure, you have to have a stable manure, so to avoid the pathogens in soil, because manure can have some, of course, pathogen also. But if you have for example, composted manure or well stabilized manure, you can use it, because manure is rich of nutrient organic component and can add more nutrients to soil. But we have to pay attention to have a well, because the composting processes with the thermal phase and mesophilic phase, the thermophilic phase with the temperature sanitize a bit the raw material that you use to compost from the transformation processes. So the fresh manure can have pathogens. So it's better to have a manure more stable, decomposed.
Okay, thank you. So I think this also linked to another question that what are the factors to be considered before choosing organic materials for organic fertilizer production? So what's the key factors we need to consider before we choose this material to be used as organic fertilizers?
But I don't understand that. Before to add this fertilizer to the soil, what I have to test in the soil, or what I have to test in the fertilizer produced?
What we need to test for the resources, the organic resources, to ensure they are safe, they are good for
of course, you have it's depend on what kind of a resource you use, before to add to the soil. Because if you use some materials that can have heavy metals or pathogens, you have to test this one, because generally these are dangerous for the human health and the soil health. But if you use, for example, some waste like that are not contain naturally this kind of pests or pathogens or heavy metal, you can use this one. Generally they are composted. Also, for example, vermicompost is a really important procedure, because you can use this to produce organic fertilizer. You use the worms, and they are indicative also if they contain pathogens or heavy metals, because they there is the death of the worms if some things it's not too good. But at the end, if you use worms, for example, you short the composting processes, because it's the half of the composting process that come naturally, because are really fast, these processes. And then the vermicompost is really rich in nutrients also.
Okay, so I think another question for you is that, did you have experience using wastewater sludge as fertilizers, as organic fertilizers, and is that good for us to use wastewater sludge?
Water?
Wastewater sludge.
The water, I don't understand.
So it's water waste in the waste.
Water waste. The wastewater. Wastewater. Okay. Wastewater depends on what kind of wastewater do you want to use. I don't know, because if I worked with the Tunisian people on the treated wastewater, because we used this to water some species, but the treated wastewater had they was in the limit of pathogen use and heavy metal use, that because we analyzed, and then they used this wastewater because they was below the limit permitted by Tunisian government for the use of this wastewater. They have to test pathogens, heavy metal, and then if they don't have this, they can use the wastewater because they contain nutrient and carbon also.
Okay, thank you very much. There is another question regarding to farmers. Sometimes it's difficult for farmers to use organic fertilizers. So how we can improve the capacity of smallholder farmers to produce and enhance the quality of their soils by using organic fertilizer? How to work with farmers and build their capacity? Do you have some good experiences regarding to build capacity for farmers, for you encourage them to use organic fertilizers?
I don't know. The farmers, it depends, because if they are able to produce, for example, compost on farm, because they have the waste, they can also produce on their own the fertilizer. At the beginning, they can use both chemical and organic fertilizer mixed together. And then when they have the capacity to produce the compost, because you don't have to use a big quantity, it depends on the farm, of course, of compost, but you enrich the soil step by step. You can produce the compost on farm with the household and everything else that you have, food waste, house waste, what remain from cultivation, you can produce compost.
Okay, thank you very much, Professor. So we asked a lot of questions. Thank you a lot for your answers. So now I would like to select questions to other colleagues. So, for example, Vanessa, there are questions about the INSOILFER working groups. How INSOILFER network can support the nutrient budgeting and mapping, and how we can supporting people, partners regarding to the soil nutrient monitoring, soil nutrient mapping, etc. Please.
Well, so far that topic, that area is being covered by the working group 1. So working group 1 will be leading to supporting, not mapping per se, but supporting the mapping activities by identifying what is the best way to identify and localize the nutrient budget, where the nutrients are in the different regions of the world. So that is the work of working group 1. We are just starting. Very soon we will have the working group specific meetings to start working the different activities per working group. So please stay tuned, and we will let you know when these meetings take place very shortly, probably in the next, we will let you know for sure the dates and all that.
Okay, thank you, Vanessa. Another question to George, the chair of INSOILFER. George, are you here? Hello? Yeah,
I'm there.
I see a question from, I think from Africa country and Nigeria, and they want to join the INSOILFER network. So how the collaboration between the INSOILFER network and the partners, different partners, for example, the Department of Soil Sciences of the Agriculture University, something like that. So how we work with partners to involve them in the network, and what we are going to work with them to implement some activities to. So please.
Yes, thank you, Yushin, for the floor. I think that is very interesting question that opened the door for explaining the collaboration with other colleagues and other institutions. As we mentioned, we have a reference institution, we collaborate with them, but we are opening for everybody want to collaborate with us. For instance, let me take an example of webinar capacity building. If there is some colleagues at the Institute of, in Nigeria, Institute of Soil Science, they are welcome to contact us, and then we can organize together or whether a webinar or a series of activities that can help the area to grow and to achieve soil fertility and fertilizer management in general.
Okay, thank you very much, George. I'm still collecting. There are many more and more questions. So I think this question perhaps can answer by Vanessa. So how INSOILFER network address the issues of greenhouse gas emission reduction and growing water deficiency? So how we can address those soil fertility fertilizer issues to the greenhouse gas emission reduction and maybe water deficiency as well, please. Vinisa.
Thank you, Yuxin. That is before that. Well, that is the work of a specific that will specifically be addressed by Working Group 2, soil fertility and fertilizer management. So we are interested in compiling and understanding, identifying, and better knowing which are the sustainable soil management practices that, in addition to increased crop yields, are focused on reducing externalities such as nitrous oxide or methane or CO2 emissions. So that is included in the work plan of Working Group 2, and it will be addressed basically by first identifying the best practices, and second, disseminate these practices that can help to reduce greenhouse gas emissions and pollution. And Yuxin, can I take this opportunity to say very quickly that, because I have many questions for that, if you are not an INSOILFER member yet, please complete the format that I just put in the chat. If you are already a member of INSOILFER and you want to be a part of another working group, please contact me. I will put my email in the chat. Thank you.
Okay, so Vinisa, I think another question is relevant to the fertilizer quality assessment. So the question is about what will be the protocol on quality assessment of fertilizers, organic, inorganic, mixed. What's the protocol and what we are doing to supporting this activity to ensure the fertilizer quality, please.
Thank you, Yuxin. We are currently actually developing and harmonizing protocols for the quantification of quality of organic and inorganic fertilizers, so that including different sources. So probably that is the topic for another a whole session, but we are assessing nitrogen, phosphorus, and potassium content in organic and inorganic fertilizers, and also heavy metal content. And we will start this year with biofertilizers. Thank you.
Okay, thank you, Vinisa. Thank you, Vinisa. I see there are a lot of questions coming, and I'm sorry because it's due to the time limitation, we cannot answer all questions from you for today's webinar. So we will save all your questions and then we will answer them in the website of the report. And another group of questions is about, can we share our presentations and recordings to you? Sure, we will share our recording and all the presentations on our website. You can download, you can review it in our website freely, and we will share this link to you by email after we download the recording, we develop the report. We will share them together with you by email. So don't worry, you will have all the materials with this webinar, and it's free. So thank you very much. And I think we had a very good webinar today. We talked about the organic fertilizers. Can organic fertilizer replace chemical fertilizer? This is always very key questions to the soil fertility and fertilizer society. And from the professor answer, yes, we can replace chemical fertilizers, but with other conditions, it's better we integrate organic fertilizers and other kind of fertilizer together to ensure the food security and also the mitigating climate change. So that is very clear. But in the future, we hope we can improve our practices on soils and to improve the quality of organic fertilizers. Then we can really work on the organic agriculture in the future. And also other audience mentioned that it's very important, the quality of fertilizers, the protocol, and also the SOPs to ensure the quality of fertilizer, very important, fundamental, because we need to work inside this network and with other NGOs, other partners together to work on the fertilizer quality insurance. That we should input nutrients that are safe. That is very important. And the last, our network warmly welcome you. Warmly welcome all of you to join our network. We are going to working on the soil nutrient monitoring, food practice exchanges, sharing, and the fertilizer quality assessment and the insurance. So we warmly welcome you to join our network INSOILFER, International Network on Soil Fertility and Fertilizers. So thank you very much, and thank you very much for participating in today's webinar. We will organize a series of webinars on the topic of soil fertility and fertilizer management and in the upcoming years. And we really hope to working with you together to manage our soil fertility and fertilizer sustainably and ensure the food security and mitigating climate change. Thank you very much. Thank you very much, colleagues. So I think it's time to close today's webinar. And please keep in touch with us by the emails, by our website. You can freely to review our website and registration your institute and your organization, your companies to the network. Thank you very much, colleagues. And have a good day, good night, good afternoon, depends where you are. Thank you very much, colleagues.
Thank you.
Thank you. Bye-bye. Thank you, Professor.
Bye.
Thank you very much.
Bye.
Thank you. Bye. Vinisa. Sorry. If you have to send the presentation, send my last presentation that I sent you this morning, because it's I just not to the presentation that you shared this afternoon, but I sent you at 12 o'clock another presentation because I have changed some things that is better.
Let me check, Adele, because
if you want, I can send you again.
Yeah, because I don't have it in my email.
Okay, I can send you again. Okay.
Yes, please.
Okay. Okay, I will send you now.
Please just to update it and upload it in the website.
Yes, I can send you.
You can send to us by email.
Okay, and you can. Okay, thank you.
Thank you very much. Thank you. Thank you for your contribution.
Bye.
Okay.